Okay, so let's have a look at the PC or laptop's view of the world on the right hand side, and also what's going to become our SSH server, which is the Raspberry Pi in the middle here. I've taken them and put them on the same LAN, so I've taken away the firewall and gateway router for the time being, so they'll see each other, and we'll see those as .84 as the SSH server, and over here the laptop in fact will be .200, so 192.168.1.200 on the right hand side. So let's have a look and see what the registry has for us. So we're going to do a regedit, so into here and simply regedit. Yes indeedy. And we can see the registration. Now I've been in here, had a little bit of a dig and a delve. So I've been having a look at VNC, and particularly the VNC viewer, which we'll use, and also SimonTatham's, and of course this is talking about PuTTY, and this is effectively what I'm going to be using as the SSH client. So I'm going to establish those. So I'm looking here at the SSH host keys. So this is the public keys that are being advertised by the various servers. If I look down this long list, I will not find mention of number 84. 81 there, yes, but no mention of 84. Okay, good. That's correct. So at the moment in time, we're not aware of this device. So let's try and establish a connection to it. So using PuTTY, and if I just scroll a ways down, because I'm particularly lazy, I've already got Raspberry 84 in there, so load that in. Now I haven't done anything special here. All I've done is identify, of course, that it's pi at and then the IP address, and I'm using port number 22. That's assuming, of course, that the device is actually listening on the default port. You may well have changed that for security, and I will do that later. So if we look at secure shell, we can see there's a number of elements down here, including the key exchange mechanism. So we're going to rely heavily upon Diffie-Hellman, of course. And we can see then the authentication. Could be using Kerberos's GSS API and the likes, TTY settings. X11 will be important for us later, so to enable X11 forwarding, and we may also use the X display location if we want to run from the server on the local machine graphical windows, so we can do that as well. Tunneling, so we'll do some forwarding through these tunnels, so using port forwarding through SSH, so that once we get to the end of the tunnel we can then redirect the requests to other machines, other devices. So these areas we'll come back and have a look at and make some modification to those a little bit later. But as it stands, I haven't got anything in the way of a private key. There's nothing listed in here. So we're not using key methods in terms of authenticating the user. We're just going to be defaulting back to effectively usernames and passwords. So here on the data, I could auto log in and put the Pi in here instead. That's a possibility as well. But here we go. So there's a few other things in here, sort of standard to connections with regards to windows and font sizes and colors that are going to be used. So you might want to go and look at appearance and change the font size, and you might want to go into colors and change the actual color scheme as well. Okay, but those are things to do at your leisure, which are sort of standard to a TTY terminal. Once it's established, we're going to establish that using good old SSH. So keeping an eye on things would be a good idea. So before we sort of trigger this request off, and bearing in mind we've already looked in the registry to see that there's no actual public key been allocated to us from the SSH server, so we've had nothing in there as yet. So let's have a look, see how that's carried, and the best way to do that, of course, is to use Wireshark. So if we have Wireshark running, and I'm looking for port number 22, and I'm going to do this against a particular connection, which will be my local area connection. We see the activity there. Okay, so if we just fire in the hole and away we go. So you can see there's no traffic there as yet, which is good. Okay, because we're just looking for SSH on port 22. Again, you'll need to change that if indeed you have. So we're looking at PuTTY, and we're looking at firing that one off, which we will. and we'll see what happens in terms of Wireshark behind. So you can see there's some Wireshark activity already taken place here. So if I just click on here and then do a Control M, we'll highlight that packet where it stands. And as we can see, that's up to and including the point where we can see that the server's host key, so that's their public key, is not cached. So we can see there's a fingerprint against that key, and it's basically asking us, do we trust this? And you may have the fingerprint, you may have it on a file which is associated with the servers that you're expected to connect to, that's provided by your IT function, and you can compare the signature. I trust this one, so in this case I'm going to say yes, but of course it could be an untrusted server, so we do have to take care. It's particularly true if this value changes and you get a prompt saying that the stored key it doesn't match, and therefore you need to make a change. That could very well be a man-in-the-middle attack, so be very, very careful. So yes, no, and cancel. So yes for us, and that then triggers off some more activity in the background. And we've got up to the point where we've actually got a prompt. So I put in the password. So I am still using passwords here, and there we go. That brings us to the login, or at least all the way through login, and we're now at that prompt. So we can see that that's the sort of end of the sequence there. So I can stop that. Let's just stop any further activity. We scroll the ways back, and we can see that first point in the chain where we can see on packet 18, that, if you remember, is up to the point where we were actually presented with the signature to the certificate, and that follows the Diffie-Hellman exchange, which is a reply, and it's coming from 84, which is the server, going to 200, which is the requesting device, the PC in this case as it happens. So that's the device bottom right in the diagram. So we've got a Diffie-Hellman group exchange, reply, that's the first part of the message, and new keys, which is the second part. So we can see here we've got this taking place, so there's effectively a two-part message. So we can see that effectively we've got the key exchange taking place down here, as well as what we can see up here is the group exchange reply. So we can see that, and we can see new keys. So that effectively is telling us at this point that the server is happy. The final part of that, of course, is the client being happy, and this is where the client new keys comes in, which is after we've accepted that particular certificate. So that should be in play, and of course that then takes us all the way through here. We can see that pretty much then everything after that then is encrypted. Yeah, the other bits here just acts, so of no significance, we might say. So we can see encrypted packets all the way through, and that corresponds to the fact that we accepted that. So the login itself, the exchange of the password, was in fact encrypted. So you can see the sequence starts off with a TCP exchange in the normal way, and then we see this identifying their SSH credentials, bit PuTTY on one end and Raspbian at the other. And then we can see that going to a client key exchange and server key exchange before then starting off the Diffie-Hellman group exchange requests and then subsequent replies. So that's a normalish Diffie-Hellman exchange with the intention of getting the known host value, the public key, into the client device. Of course, what we're doing here is we're using this key exchange effectively then to provide us with a secure session key, and it's that secure session key that's now being used to encrypt those packets. So if we have a look and we do a refresh, F5 would have achieved the same thing. If we scroll down, what we'll actually see is there indeed is number 84. Okay, so this is here we can see there's only a portion of the key is actually mentioned. If we open that up, we see only a portion of the key is actually here. Nothing like the complete key. So if we want to see that, then we'll need to go into the command prompt. This again is at the client device. So if I just rattle in, and this is effectively a REG query, and you'll see where it is. It's host keys users. Now this whole lot here is really worth a search first. So what I would recommend that you do is search for Simon, or for the SSH host keys. And if you do that, it's a CTRL F in order to search through for that, then it should actually find its way through to this point quite happily. Then if we can see what the key is down here. We can of course right click and we can copy the key name. So we now have that key name, and we can then paste that into here. And then what I've done is I've piped that through findstr, and we're looking for this string within the output there, 192.168.1.84. So I don't have to search the list, I can actually find it here. So we can see that that is the key in all of its sort of beautiful hex, and we can see that is indeed RSA2, so that's at 22, that's at that port number. So if you have different port numbers on the same server, you get different values here. Well, you'll get different entries here, and this one again 192.168.1.84. Okay, so therein lies the public key that will be used in the further exchanges. So when we exit out of that particular session, so if we come out of here and we try again with PuTTY to go into that Raspbian 84, when we open that up, there's no request for that key. So that's done automatically. We're just straight into the prompt. Now, what we'd like to do is actually like to use certificates, certificate-based authentication, as well as being used to secure the transport channel in some way. So there really needs to be two stages to this operation, so we need to complete that part, and we'll do that a little bit later. Okay, so that's sort of the activity you'll find out at the client end. Now what I've done here is I've VNC'd through to the actual server, as will be, and that's, as you can see, is most definitely a Raspberry device, a Raspbian, and we can see where we're at. We're in the home directory for Pi, which is the default user. We don't go in as root, of course. We need to sudo to that if we need to go into root, so sudo -s and you're in. We'll just come out of there for the time being. So we're in here, and we can see then, let's have a look, see what sort of stuff we've got in our directory. We've got some VNC mentions here, no SSH, so we'll need to modify that. It should be a .ssh if we're fully supportive, but as you can see, we are supporting SSH. We'll come back and have a look at that sort of side of life a little bit later. And other things that we should have of note, so if we go and cd to /etc//ssh, and if we do an ls against this, in fact we'll just do an ls, what you can see here is you've got a couple of config files to start off with. So you've got your config file here as the client, and you've got the config file as the daemon or server. So sshd_config is the first file to go and have a look at, as this is going to be the server. We've also got some host keys of different types. So we've got the RSA, we've got the ECDSA, and we've got the DSA. So we've got them both in their private form, and with the .pub at the end, their public form. So public and private keys. So there's a key pair here for each of those types. So under negotiation, the devices will negotiate which type of key type they're going to use, and then it'll be up to them to use the pair appropriately. So we can see then that we've got a range then of files in here. Of particular importance then is this sshd_config from a configuration perspective. So let's just going to have a look at the contents of that. Oh, just a thought. Let's ls again. Of course, there are some other bits and pieces in here. There's something here, SSH host key, and then it's appropriate, and it's a accompanying pub key. That's actually RSA keys for version 1, whereas the RSA key in here was actually for version 2 of the SSH protocol. So something I nearly missed. In fact, if we go back and have a look at the registry edit, and let's just prove things a little bit here. If we actually go and remove that key, so delete that entry, And then we repeat that sort of reg query for that. Of course, there should be nothing coming back perfect. And again, just to prove the point, if we go to the PuTTY session and remove that PuTTY session and go back in again, we'll see that that indeed requires us to accept the key again. And I get bored to tears of typing this password in before long. And then again, if we do we find the keys back. Okay, so if you sort of sit there and compare the keys in the meantime, you'll see that they look the same to me, right? But we can do a comparison of those if you wish, but you can do that at your own time. So just get rid of that one, and in fact, actually, let's just pull up VNC, and again, remember where we are. We're on the server. So this is the server side of the equation, and it's having a look to see what the server actually has. So we can see the keys that it would use, and of course that effectively allows us to support those transport tunnels in using secure shell. Good. Right. Let's press on. It's time to see what that looks like locally. So if we just do look at the running processes, those associated with SSHD, we should see those running. Running against root. And as far as the routing side of life is concerned, should have some stuff going on here. So we're just looking at the routing side of life and looking at those established TCP sessions. So have a look for those and look specifically for the one that's got port number 22 in it. And we can see this is operational between the server at 84 and the client at 200. And of course the server is listening on port 22. Good. So we can see there is activity there. We can see effectively what's been established as a connection through to this device. Of course, we can go and kill those if we like as well, using good old kill -9. So we'll do that perhaps when we need to a little bit later on. So the next thing, of course, is to explore the files that we have here. And in particular, as we're using this as a server, sshd_config. So that's the file that we need to go and have a look at. And of course, we can do that through a number of different means. We can go in and use nano. So we can have a look at that on an editor of your choice. And we can effectively then have a look and see what that file contains. We can cat it, of course, and have a little play with that within just the capability of viewing, so scrolling back and having a view. Of course, you could actually copy the contents out and put them onto another system, and then you can sort of play with the contents of that without any harm whatsoever to the system itself. So, of course, it's SSHD, what we're going to have a look at, and it's the config file, and we can see this is the start of that, and you can see that we're using version 2 and port number 22. We can see the host keys that have been used here. So we can see the RSA, the DSA, so that's the version 2s, as we are using protocol 2. And then we've got the other choices as well. And then there's some other settings that we will have a look at in a little bit more detail in a later recording.